Good morning class. Today we discuss Lee-Chatelier's principle. According to Lee-Chatelier's principle, if a system in equilibrium is subjected to change of concentration, temperature or pressure, the equilibrium shift in that direction where the effect will be minimized. I repeat it again. If a system is in equilibrium is subjected to change of pressure, temperature or concentration, the equilibrium shift in that direction where the effect will be minimized. Now let us discuss the factors which affecting the equilibrium. There are some factors which affect the equilibrium. Some of them are we discuss as number 1, effect of addition of catalyst on the equilibrium. It should be noted the addition of catalyst does not alter the equilibrium, but in presence of catalyst equilibrium attained quickly. I repeat it again, addition of catalyst does not affect the equilibrium, but in presence of catalyst equilibrium attains quickly. Number 2, addition of inert gas to the reaction mixture in equilibrium. It should be noted addition of inert gas at constant volume does not affect the equilibrium, but the addition of inert gas at constant pressure will shift the equilibrium in that direction where towards a larger number of moles. I repeat it again, addition of inert gas at constant volume does not affect the equilibrium, but the addition of inert gas at constant pressure shift the equilibrium towards the larger number of moles. Number third factor which affect the equilibrium is the temperature. Number third is temperature. It should be noted exothermic reaction favors in forward direction at low temperature, while the endothermic reaction favors forward direction in at high temperature. Number fourth factor which affect the equilibrium is pressure. It should be noted if number of moles of gaseous product greater than number of moles of gaseous reactant, then equilibrium shifts toward that direction where the number of moles reduces, that is in reverse direction. But if number of moles of gaseous reactants are greater than number of moles of gaseous products, then equilibrium shift, that high pressure will shift the equilibrium in that direction where number of moles reduces, that is in forward direction. I repeat it again, if number of moles of gaseous product is greater than number of moles of gaseous reactant, then equilibrium shift toward in that direction where number of moles reduces, that is in reverse direction. But if number of moles of gaseous reactant is greater than number of moles of gaseous product, then equilibrium shift in that direction where the number of moles reduces, that is in forward direction. So here we discuss some factors which affect the equilibrium. Now let us review faster. Effect of addition of catalase. I repeat again, the addition of catalase does not disturb the equilibrium. However, it helps in attainment of equilibrium quickly. Number 2, addition of inert gas as constant volume does not affect the state of equilibrium, whereas at constant pressure equilibrium shift toward the larger number of moles. Effect of change in concentration. More the concentration of reactant shift the equilibrium in forward direction where concentration of reactant reduces. It is a Lee-Chatelier's principle. Effect of change in temperature. High temperature exothermic reactions are favored by low temperature, whereas the endothermic reactions are favored by high temperature. And the effect of pressure, if number of moles of gaseous product is greater than number of moles of gaseous reactant, then high pressure will shift the reaction in that direction where number of moles reduces, that is in reverse direction. If number of moles of gaseous reactant is greater than number of moles of gaseous product, then high pressure shift the reaction in that direction where number of moles reduces, that is in forward direction. So these are the 5 factors which affect the equilibrium. These are, I repeat again, these are number 1, addition of catalase. Addition of inert gas, temperature, pressure and the concentration. More the concentration of reactant, more will be the rate of forward reaction according to Le Chatelier's principle. So here we discuss Le Chatelier's principles and the factor affecting equilibrium. Now let us come on the next topic, electrolytes. Electrolytes are those substances whose aqueous solution or molten state conduct electricity. I repeat it again. Electrolytes are those substances whose aqueous solution or molten state conduct electricity. For example, NaCl, KCl, etc. Electrolytes are of two types. Student, electrolytes are of two types. First type of electrolytes are the strong electrolytes and the second type of electrolytes are the weak electrolytes. Strong electrolytes are those which produces large number of ions when dissolved in aqueous solution or in molten state. They completely ionize in aqueous solution. Example of it are NaCl, KCl, etc. While the weak electrolytes are those which partially ionize in aqueous solution and produce less number of ion. Example NH4OH and CH3COOH, or in short we can say that strong electrolyte conduct electricity in large extent but the weak electrolyte conduct electricity in lower or small extent. Like I repeat again, electrolyte are those substances whose aqueous solution conduct electricity in molten state or aqueous state. Two type of electrolytes are there, strong electrolytes and weak electrolyte. Strong electrolyte are those which produce large number of ions when dissolved in water, while the weak electrolytes are those which produce less number of ion when dissolved in water. Example of strong electrolyte NaCl, KCl, and weak electrolyte is NH4OH, CH3COOH. So these are the electrolytes and their type. It should be noted the word dissociation. The word dissociation is used for ionic compound when dissolved in water, and the word ionization is used for covalent compound when they dissolve in water and dissociate into ion. For example, when we add NaCl in water, NaCl dissociate in water as Na positive and Cl negative, while when HCl added in water, it ionizes into H positive and Cl negative ion. Or in short, we can use the word dissociation for ionic compound and word ionization for covalent compound. Now the question arises, how the dissociation take place? It should be noted, students, NaCl is an ionic compound when it added in water. Since water has high dielectric constant approx 81, which decreases the electrostatic force of attraction between the opposite charge ions, thus they dissociate in aqueous solution and dissociation take place. I repeat it again. When NaCl added in water, the high dielectric constant of water approx 81 dissociate H positive, dissociate Na positive and Cl negative ions, and dissociation take place. Students, it should be noted sugar, alcohol are the example of covalent compound but soluble in water because they contain large number of OH bond, or we can say that due to formation of hydrogen bond with water molecule. I repeat it again, sugar, alcohol are the example of covalent compound but soluble in water because they form hydrogen bond with water molecule, or we can write it due to the presence of large number of OH group in them. Now let us come on the next topic, ionization of weak electrolyte and Oswald dilution law. Now let us discuss ionization of weak electrolytes. Ionization of weak electrolytes within bracket Ostwald dilution law. Now let us take an example. We have an acetic acid which is an example of weak electrolyte. When added in water, it produces acetate ion along with hydronium ion. Suppose initial concentration of acetic acid will be C. These are not produced at equilibrium. Suppose alpha mole of acetate ion and alpha moles of hydronium ion produced whose concentration are C, then 1 minus of alpha of these are dissociate. Now the value of K for this reaction is concentration of acetate ion into concentration of hydronium ion divided by concentration of acetic acid into concentration of water. But we know that since it is a dilute solution, so the product of K and concentration of H2O should be taken as A. It is a dissociation constant for acid. It is taken as dissociation constant for acid. Therefore, we have Ka is equal to concentration of acetate ion into concentration of hydronium ion divided by concentration of acetic acid, and their values are given. Now putting their values, Ka is equals to C alpha into C alpha divided by C1 minus alpha. We get C alpha square upon C1 minus alpha. Cancelling like terms, we get this term. Now for dilute solution, 1 minus alpha is approximate, it taken to be 1. Thus Ka is equals to C alpha square. Thus the value of alpha is equals to under the root Ka upon C, or we can say that alpha is inversely proportional to the square root of C. That is the Oswald dilution law. I repeat it again. Acetic acid or ionization gave acetate ion and hydronium ion. Equilibrium constant expression is written as like this way. But the product of K and H2O is taken to be Ka. It is a dissociation constant for acid. Now put the values of concentration of acetate, hydronium and acetic acid from equation. We get this one. Now we are taking 1 minus alpha approximate equal to 1 because it is a dilute solution. So Ka is equals to C alpha square. Thus the value of alpha comes out to be Ka upon C. That is alpha is inversely proportional to square root of C. That is the Oswald dilution law. So according to Oswald dilution of law, the degree of ionization of weak electrolyte is inversely proportional to the square root of their concentration. I repeat again. The degree of ionization of weak electrolyte is inversely proportional to the square root of its concentration. It is the Ostwald dilution law. Now, let us consider the next topic, acids. As we discussed in class 10th, acids are those substances which produce H positive ion in aqueous solution. Now, here three concepts are there for explaining the term acid. Let us discuss one by one. Acids. Acids according to Arrhenius concept. According to Arrhenius concept, acids are those substances which produce H positive ion in aqueous solution. I repeat again. According to Arrhenius concept, acids are those substances which produce H positive ion in aqueous solution. While according to Bronsted-Lowry concept, Bronsted-Lowry concept, acids are proton donor. According to Bronsted-Lowry concept, acids are proton donor. And the third concept is the Lewis concept or modern concept. It says acids are electron pair acceptor. Example is BF3, AlCl3, etc. In this HCl, etc. According to Lewis concept, acids are electron pair acceptor. Similarly, we can define bases. According to Arrhenius concept, bases are those substances which produces OH negative ion in aqueous solution. According to Bronsted-Lowry concept, bases are the proton acceptor, and according to Lewis concept, bases are the electron pair donor. Example of electron pair donor bases are NH3, PS3, etc. It should be noted, acid is said to be strong. It produces large number of H positive ion when dissolved in water and conduct electricity in larger extent, while the acid is said to be weak if it conduct electricity in a small extent and to produce less number of H positive ion in aqueous solution. Now let us discuss the factor which affecting the acid strength. it should be noted the acid strength depends on two things. First is weaker the Ha bond. Weaker the Ha bond, easily it will disassociate, stronger will be the acid. I repeat it again. The factor affecting acid strength, factor number 1, strength of Ha bond. Smaller the extent of Ha bond, easily the bond disassociate, stronger will be the acid. The second factor is the electronegative difference between H and A. More the electronegative difference between H and A means easily the bond disassociate, hence greater will be its acidity. Therefore, we can arrange acidity as HF, HCl, HBr and HI accordingly. Since on moving down the group, ionic size increases, bond disassociation and enthalpy decreases, that is the bond disassociate easily take place, thus HI will be the stronger acid as compared to HF. Now let us discuss conjugate acid base pair. Conjugate acid base pair. The acid base pair differ by proton. I repeat again. The acid base pair differ by proton is said to be conjugate acid base pair. If we are adding H positive ion in base, then we will obtain conjugate acid. I repeat again, conjugate acid base pair are those which is only differ by proton. Suppose we have a species, their conjugate acid, conjugate base we are written as, suppose we have water, on adding H positive ion, conjugate acid become H3O positive. If we remove H positive from here, we obtain conjugate base, this one. Let us take an example of ammonia. For making conjugate acid, adding H positive, we get NH4 single positive. For making conjugate base, remove one proton, that is NH2 single negative. Similarly, we can write H2SO4 as a species, their conjugate acid not known, and the conjugate base will be HSO4 single negative ion. Suppose we have SCO3 single negative. For making conjugate acid, we adding H positive ion in it, so we get H2CO3. And for making base, remove H positive ion, we get CO3 2 negative. So we can understand that conjugate acid is obtained by adding H positive ion to the species, and conjugate base is obtained by removing H positive ion to the species. That means the conjugate acid base pair are those which are differ by a proton. I repeat again, conjugate acid base are those which are differ by protons. Now let us discuss ionic product of water. Student, ionic product of water is indicated by Kw. Ionic product of water is indicated by Kw. It is defined as the product of molar concentration of hydronium ion and OH negative ion. I repeat it again. Ionic product of water is defined as the product of molar concentration of hydronium ion and OH negative ion, and its value is 1 into 10 raised to power 14 at 298 Kelvin. Its value becomes 1 into 10 raised to power 14 at 298 Kelvin. So ionic product is defined as the product of molar concentration of hydronium ion and H positive ion. It should be noted the value of ionic product of water increases by rise of temperature, because on rising the temperature, ionization take place rapidly. Now let us discuss pH. pH is defined as the power of hydrogen. The term pH was coined by the scientist Espen Sorensen in 1909. pH is defined as power of hydrogen. It is defined as the negative logarithm of hydrogen ion concentration. Since H positive ion exists as hydronium ion in water, thus pH may be defined as negative logarithm of hydronium ion concentration. With the help of this formula, we can calculate pH. Here we must know pH scale. pH scale is divided into 14 parts. These are, it is already discussed in class 10. Here the 7 part indicate neutral. Here the 1, 2, 3, 4, 5, 6. Here the basic strength increases, here the acidic strength increases. Here the acidic strength increases, here the basic strength increases. Also, P of OH is also calculated with the help of formula log base 10 concentration of OH negative ion. Here is the relationship P of H plus P of OH is equal to P of KW. It is equal to 14. We must memorize these formula by heart because it is very helpful for solving various numerical given in NCERT and other refresher books. Now, let us solve a numerical problem based on pH. Suppose we have to calculate pH of solution having concentration 10 raised to power minus 3 HCl. We know that HCl is ionized as H3O positive plus Cl negative. Therefore, the concentration of hydrogen ion here 10 raised to power minus 3. And we know that pH may be defined as the negative logarithm of concentration of hydronium ion. Now put the value of concentration of hydronium ion here. We get power आगे आ जाएगा. Then pH is equals to plus 3 log base 10 10. Log base 10 10 value is 1. Thus the pH of solution calculate to be 3. Suppose we have to calculate pH of 10 raised to power minus 4. Suppose we have to calculate pH of 10 raised to power minus 4 MnAOH. NaOH on dissolve in water produces Na positive plus OH negative. In this case, the concentration of OH negative is 10 raised to power minus 4. We know that P of OH may be defined as the negative logarithm of OH negative ions. Now put the value. Here the concentration of OH negative is 10 raised to power minus 4. We get this quantity. Log base 10 10 value is 1. Then P of OH calculate to be 4. But we know that P of H and P of OH is equals to 4. Thus the or implies pH plus 4 equals to 14. Thus the value of pH calculate to be 10. With the help of this formula, we can calculate pH of any solution.